Hi, everyone. Welcome to the Arctic Report Card 2014. I'm going to introduce Monica Allen from NOAA Communications.
Thanks, Nancy, and thanks everybody for coming today for the Arctic Report Card 2014 press conference. I'm Monica Allen, as Nancy said, from NOAA Communications, and I'll be here if you have any questions afterwards, if you need anything, any materials. We have a lot of stuff up on the web, so there's a lot there to help you with your stories. And I'd like to introduce our panel today. We have Craig McLean, the Assistant Administrator for NOAA's Office of Oceanic and Atmospheric Research. Craig is in the middle. We have Martin Jeffries, who is the Arctic Science Advisor and Program Officer for the Arctic and Global Prediction Program in the Office of Naval Research. We have Jacqueline Richter-Menge, who's a Senior Research Engineer at the Cold Regions Research and Engineering Laboratory. And on the phone, we have Jeff York, who is a Senior Director of Conservation for the Polar Bears International. We also will, during the question and answer portion of the card, have a number of people in the room. We have a number of scientists who are authors, and we will have on the phone Mike Gill, who is with the Canadian High Arctic Research Center. And now I'd like to turn this over to Craig.
Thank you and good morning. My name is Craig McLean, and I'm currently acting in the position of Assistant Administrator for NOAA's Oceanic and Atmospheric Research. Climate change is having a disproportionate effect on the Arctic. For the past 30 years, the Arctic has been getting greener, warmer, increasingly more accessible to shipping, energy extraction, and fishing. These changes, due to rising greenhouse gases, are creating major challenges for the people who depend upon the Arctic's natural resources for sustenance and for cultural identity. They're also affecting people and climate outside of the Arctic region. The United States is increasingly making the Arctic a focus, as a focus of national attention. Last year, the U.S. released a national strategy for the Arctic, and earlier this year, NOAA outlined an Arctic action plan to build upon 3 of the national strategies, and these include to advance U.S. security interests, to pursue responsible Arctic regional stewardship, and to strengthen international cooperation. At the foundation of each of these goals is sound scientific information, and we're here to share that with you today. We base decisions that help support resilient communities and resilient ecosystems that are facing these changes. First begun in 2006 and updated annually, this Arctic Report Card provides foundational scientific information that's essential to decision makers. The report is also an example of outstanding international scientific collaboration. 2015 is a particularly important year for the United States in the Arctic. In April of next year, 2015, the United States will assume the 2-year rotating chairmanship of the Arctic Council, the group of 8 Arctic nations. We're very excited about that, and together with the other Arctic nations, we hope to get a lot of important work done. Some of the priorities that we'll be proposing to the Council are key topics for the scientists here at the AGU meeting. We'll work to prioritize scientific research on climate change, to include mitigation of short-lived climate pollutants such as black carbon and methane, and look at Arctic ocean acidification, adaptation, and resilience. Regarding resilience, I remind you that at 12:30 today, Catherine Sullivan, the administrator of NOAA, will be presenting her keynote and plenary remarks on the subject of community resilience, and I think that would be very relevant to many of the subjects that will be raised here today. A major goal of the report card and our climate and Arctic focus is to raise awareness of the Arctic across the United States so that the American people can understand that the United States is an Arctic nation, that Arctic matters to people from all aspects, from strategic, climatological, national security, and many other perspectives. It's now my pleasure to introduce Dr. Martin Jeffries, who has served as editor-in-chief of this year's report, and I ask you to welcome him. Martin.
Thank you, Craig. I'm pleased to add my welcome to you today to the official release of the 2014 update to the Arctic Report Card. This is the 8th annual update to the report card, which was first published in 2006 as the State of the Arctic report. This year's report card is the work of a large international team of 63 authors from 13 different countries. All 10 contributions, or essays as we prefer to call them, in this year's report card were subject to independent peer review organized by the Arctic Monitoring and Assessment Program of the Arctic Council. The report card is published online, where key highlights from the essays and a video that summarizes Report Card 2014 can be seen on the front page of the website, which will go live any moment, I believe. So I'll turn to Jackie to begin to tell us about what was happening in the Arctic in 2014.
Thanks so much, Martin. Well, in 2014, we continue to see the impact of a persistent warming trend in the Arctic that began over 30 years ago. We also continue to see the influence of significant year-to-year and regional variations. Now, central to the story are Arctic air temperatures, which have continued to increase at a rate of warming that is more than twice as fast as lower latitudes. This well-documented effect is called Arctic amplification of global warming. In early 2014, the warm Arctic atmosphere was strongly connected to lower latitudes as the polar vortex weakened and the waves in the jet stream became more pronounced. These conditions allowed cold air to move southward from the Arctic into the eastern North America and central Russia, while the warm air flowed northward into Alaska and northern Europe. In Alaska, temperatures reached more than 10 degrees Celsius higher than average in January. Now, responding to the persistent warming air temperatures, snow cover extent across the Arctic during the spring of 2014 was below the long-term average experienced over the period of 1981 to 2010. A new record low extent was set in April in Eurasia, and North America's June snow extent was the third lowest on record. Snow disappeared 3 to 4 weeks earlier than normal in western Russia, Scandinavia, the Canadian subarctic, and western Alaska. This was due to below average snow accumulation in the winter combined with above normal spring air temperatures. Now, the extent of the sea ice cover in September 2014 was the 6th lowest since satellite observations began in 1979. It also marked the 8th lowest sea ice extent to have occurred in the last 8 years, in other words, from 2007 to 2014. Interestingly, the rate of the summer sea ice loss is now exceeded by the rate of reduction in the northern hemisphere snow cover extent in May and June. Now, as sea ice retreats in the summer, sea surface temperatures in the marginal or coastal seas of the Arctic Ocean are increasing. This trend is most apparent in the Chukchi Sea, northwest of Alaska, where sea surface temperature is increasing at a rate of 0.5 degrees Celsius per decade. In August of 2014, sea ice retreat occurred relatively early in the Laptev Sea north of Russia and then the Bering Strait between Alaska and Russia. In these regions, sea surface temperature was as much as 4 degrees Celsius higher than the 1982 to 2010 average. Larger regions of open water can also be linked to increase in the production at the base of the food web, due to the increase in the amount of solar radiation available for photosynthesis and in the availability of nutrients. In June, July, and August of 2014, the highest levels of primary productivity occurred in the Kara and Laptev Seas north of Russia. The timing of phytoplankton blooms throughout the Arctic Ocean is also being affected by the loss of sea ice, with more frequent secondary blooms occurring during the autumn. We are also seeing that there is growing evidence that the sea ice cover is affecting polar bears, and today Jeff is going to talk to us about that evidence.
Thanks, Jackie. Indeed, in areas where we have long-term data, there are troubling signs for both polar bears and other animals that depend on ice for cover and survival. For example, between 1987 and 2011 in western Hudson Bay, Canada, a decline in polar bear numbers from around 1,200 down to 800 approximately can be linked to earlier sea ice breakup, later freeze-up, and thus a shorter sea ice season. In the southern Beaufort Sea, where there are now twice as many ice-free days over the continental shelf as there are immediately to the west in the Chukchi Sea, adult polar bear numbers stabilized at around 900 by 2010 after a 40% decline since 2001. The survival of young bears in the southern Beaufort Sea also declined between 2001 and 2010. In contrast, polar bear condition and reproductive rates in the adjacent Chukchi Sea appear to be stable at present. This is potentially due to greater productivity of that system, fewer ice-free days over the continental shelf, and a possible rebound from significant harvests in the mid-90s. Martin?
Let's return to the land, where there's additional evidence of the impact of the persistent warming trend. Peak tundra greenness, a measure of vegetation productivity and biomass, continues to increase. Between 1982, when observations by satellite began, and 2013, tundra biomass increased by about 20%. On the Greenland ice sheet, melting occurred across almost 40% of the ice surface in summer 2014. And for about 90% of the summer, the extent of melting was above the long-term average for the period 1981 through 2010. Also, the number of days of melting in June and July exceeded the average for the period 81 through 2010 over most of the ice sheet. Then in August of 2014, the reflectivity or albedo of the ice surface, which affects the surface energy balance and thus melting, was the lowest observed in the satellite record, which dates back to the year 2000. The Arctic is not without its mixed signals, however, due largely to the effects of year-to-year and regional variation. For instance, at the time of maximum ice extent in March, there was evidence of a modest increase in sea ice thickness compared to 1 year previously in March 2013. On land, where, as I mentioned earlier, tundra peak greenness continues to increase, the greenness of the tundra integrated over the entire summer has actually been decreasing in Eurasia. This so-called browning trend and a decrease in the length of the growing season has happened as summer air temperatures in that region have been decreasing. Perhaps most surprising was that the total mass of the Greenland ice sheet remained essentially unchanged between 2013 and 2014. There was a small loss in mass, but it was negligible compared to previous summers. So how could we sum up the state of the Arctic environmental system? The impacts of the persistent warming trend of over 13 years remain clearly evident in the land and ocean environments, and these impacts are influencing the Arctic, marine, and terrestrial ecosystems. Given consistent projections of continued warming temperatures, we can expect to see continued widespread and sustained change throughout the Arctic environmental system. But we won't see those changes if we don't at least maintain and sustain our current long-term observing capabilities. Indeed, if we're to understand how this complex environmental system works, if we're going to improve predictions of what's likely to happen in the future and identify appropriate responses to the anticipated changes, we really need to add to our Arctic observing capabilities. Observations are fundamental to Arctic environmental awareness, government and private sector operations, scientific research, and science-informed decision-making, as required, for example, by the US National Strategy for the Arctic region. Before we close and I open to questions, I'd like to acknowledge the work of a number of people who are vital to the success of the report card. First, the Arctic Report Card is supported by the NOAA Arctic Research Program. Kathy Crane is the program manager for that program. Second, I'd like to thank the authors who generously volunteer their time and expertise in preparing the essays. Third, our first ever editorial advisory board, which helps us identify essay topics and authors and assists with the internal review. Fourth, Nancy Soraidi and Tracy Nakamura, who prepare the report card website hosted at NOAA Pacific Marine Environmental Laboratory in Seattle. And last but not least, I'd like to thank my co-authors, Jackie Richter-Menger of the Cold Regions Research and Engineering Lab in Hanover, New Hampshire, and Jim Overland down here at the front from the NOAA Pacific Marine Environmental Lab in Seattle. So with that, that concludes the update to the Arctic Report Card for 2014, and I'll open the floor to questions now. Thank you.
Okay, any reporters in the room have questions?
Yes, Randy Shostak, reporter with EOS. Thanks very much for holding this press briefing. I'm wondering, what are the big surprises and what are the big differences in this year's report? You mentioned, for instance, that perhaps the most surprising is that the total mass of Greenland ice sheet remained essentially unchanged. I wonder if you can explain, give me your explanation for that, and tell me what are the other big surprises in this report and big differences here.
Well, if I may, I'm going to put Marco Tedesco on the spot, and perhaps, Marco, you'd care to address that. Marco is the first author of the Greenland ice sheet essay.
Hi. So the Arctic Report Card classically look at the data itself. We try to interpret with other tools. The main reason we believe it is so is because there was more accumulation on the southeast part of Greenland than previous years, and there was less melting and runoff on the west part with respect to the long-term trend. So there was less melting on one side and more snow on the other, and Grace takes a picture of the whole ice sheet, and so those two components were balanced for 2014. Marco Tedesco, I'm the lead author for Greenland and currently with the National Science Foundation.
Thanks, Marco.
Eli, go ahead.
Martin, he had a follow-up.
This is
Randy has a follow-up.
Oh, okay. Well, go ahead.
This is a question for Jacqueline. You mentioned that you said primary productivity had risen in the Kara and Laptev Sea. The report mentions an increase in chlorophyll measured by satellite. Can you talk about what we know from that chlorophyll?
I'm going to again pitch to one of the authors. Martin, you were keeping track of the authors that
Yes,
are in the room.
right in front of you, Joey Camiso from NASA Goddard Space Flight Center. He's one of the authors of the primary production essay.
Yeah, we've been monitoring the chlorophyll concentration in the Arctic for the last 12 years or so, since 1998. And there's some variability, interannual variability, but there was a big rise in 2003, for example. It leveled up there. And for 2014, it was enhanced. And the reason for that, I think, is maybe more melt in the region. And what melting of ice means is that you introduce a layer of fresh water, melt water, that has a density that's much lower than the seawater. So it's a stable layer. It sees the sun all the time. And it's an ideal platform for photosynthesis. So I think that in 2014, the area was just ideal for blooming.
But the report says that we don't know that the chlorophyll needs more productivity.
The productivity increased as well.
Yeah, Randy Shostak again. I just wanted to get some clarification on the last question. So am I clear to understand that then the Greenland ice sheet finding is the one big surprise that you would point to in this report? And also, what are the major differences between this year's report and last year's?
I don't know that the decrease, the much lower loss of mass from the Greenland ice sheet is the surprise of 2014 in the Arctic. In a discussion I had yesterday with another reporter, the way I responded to a similar question was that we can't expect records every year. It need not be spectacular for the Arctic to continue to be changing. So the fact that there are not big changes and possible surprises in the report card does not mean that the Arctic does not continue to change, that these changes are, because there's no big surprise or change, that then nothing important happened.
And if I just can add to that, I mean, really what we're doing is accumulating a series of observations that are allowing us to see the power of persistence. I mean, you know, we're seeing this long-term warming trend, and that's allowing us to see more and more evidence that is, you know, pointing to the impact in the Arctic, and also really importantly to allow us to see the connections between what's happening in the different elements of the Arctic. For instance, we see the loss of sea ice. That loss of sea ice is causing the temperature in the marginal ice zones to increase. That increase in temperature is allowing us to see more primary productivity and also to see impacts on polar bears. We can also see connections between that increased amount of open water in the marginal seas and increased vegetation. So the fact that we have that persistence allows these signals to become more and more stronger and adds very, very credible evidence of the impact of the warming in the Arctic, which I think is really helpful for conveying the story.
I think it's important not to focus on just one thing. It's a system, a very complex system, and we need to look at it in that fashion. That's what we try to do in the report card by reporting on these different subjects, both physical and biological.
Hi, David Appel with Yale Climate Connections. Given the decrease in albedo in Greenland and the Arctic and snow cover, is it possible to derive like a global radiative forcing number for that feedback in watts per square meters over the entire planet?
I expect someone's working on that as we speak. I can't give you a value for that, but you're right. These changes in the albedo have a significant effect on the surface energy balance, not just of the Arctic, but of our planet. Mm-hmm. And it's very important that we be able to quantify those.
And I think you also make an important point about the fact that the decrease in albedo is happening in the Arctic Ocean, on land because of the loss of snow cover extent, and also on Greenland. Those things all combine together to reduce the albedo overall.
Do we have any questions from the chat?
Sure, I have a question from Miguel Llanos at NBCnews.com. How would you compare this year to recent years, better, worse, or more the same? And is anyone willing to provide grades to go with the report card? And if you would please say your name and affiliation for the benefit of those on the web, I'd appreciate it.
Jackie.
Fortunately, I had a reporter that asked me the same thing yesterday. It's Jackie Richter-Mengy from the Cold Regions Research and Engineering Laboratory in Hanover, New Hampshire. And I think we agreed that we could give the grade of incomplete, due largely to the fact that it is an evolving story, and also to the fact that, you know, really we, as Martin has pointed out, it's really important that we continue our commitment to making observations over the long-term period. This is not just a, you know, a little here and a little there. This is a story that needs to be covered in the long term, and one that we need to watch carefully.
I would add that, Craig McLean, NOAA, I would add that this is a class project, so the grade has to be incorporated amongst the hands of many nations working together. Thank you.
Good point.
Thank you. Do you have another question from the chat?
Sure, I have one more from Carrie Sheridan from the Agence France Presse. I understand that this is an annual report, but the data on polar bears seems to be from prior years. Is there any data from last year about polar bears in particular that could shed light on how they're faring?
Well, Martin Jeffries, Office of Naval Research. I'll begin to answer that question, then ask Jeff York from Polar Bears International to continue. But we report on the most recent available data. And in the case of the polar bears, the most recent polar bear assessment, Arctic-wide assessment, was in 2013. Hence the report, the essay in the report card focuses on the status of the polar bears in 2013 and beforehand. But Jeff, would you care to add anything to that?
Sure, I can add just a little bit. I think it's often the nature, particularly of the biological sciences, that we're looking backwards in time. By the time we collect data and then have ample time to not only analyze it for a specific year, but as others have said, put it in a long-term context with other data, years go by. And so that's why you see this lag effect where, for example, the Southern Beaufort paper that came out just a couple of weeks ago, that analysis for data ended in 2010. And you had to pick a date to end so you could begin your analysis, and that's very common.
Thank you. I have one more question from the chat related to polar bears. This is from Doyle Rice from USA Today. How overall has the polar bear population for the entire Arctic changed in the past decade or two? Up, down, the same?
I'd ask Jeff York to respond to that again, please.
Sure. Jeff York with Polar Bears International. The simple answer is we don't know globally. If you look at the most recent 2013 assessment from the Polar Bear Specialist Group, one thing that is striking is about half of the Arctic, half of the 19 polar bear subpopulations, at least spatially, are data deficient. This includes the entire coast of Russia and eastern Greenland, some fairly large pieces of real estate that we don't have monitoring data or any modern data at all in some cases. And so that global estimate is very much that. It's the best estimate that all of the circumpolar polar bear scientists can come up with, putting their heads together with historical data, habitat information, and other metrics. And so it's not as, that global number is not as sensitive to year change as we can dial in down at the subpopulation level. So that's the short, long answer.
Thanks, Jeff.
I think we have another question in the room.
Yeah, this is Susan Moran, a freelance journalist in Colorado. Another question about primary production, and some of this may be beyond the purview of your study, I'm not sure, but as you look at the trends in primary production, what are some of the implications for different fish species, including maybe the geopolitics of fishing? Or is that beyond this?
Right behind you, Jackie Grebmeyer from the University of Maryland. I'd ask her to respond to that.
It's nice to have a room full of authors, isn't it?
Yes, hi, Jackie Grebmeyer, University of Maryland, Center of Environmental Science. The primary production, it's variable. We have the satellite records give us the phenology and seasonality in the field program. For the fisheries, it depends on what scale you're going to look at. Right now, the northern Bering Sea, the bottom water temperatures keep the big fisheries from the south from coming north. But there are, along the Alaska coastal water where it's warming, you can get larval stages and fish populations going north. So there are actually some commercial size organisms up in the, just to the east of Barrow, but they're not in commercial numbers, but they're there. They're particularly snow crabs. So what you have, the answer to your question is the potential on a large scale. Right now, for example, the Barents Sea, their big fisheries they're going north. There's no question on it. Our fisheries on our side, the water system is such that we have a temperature barrier, and we have a closure on fisheries north of Bering Strait anyway. So right now, the answer is, in the short term, you could have a potential, but it depends on the water mass quality, the temperature regimes. The satellites show that we're going to increase production at certain periods of the time. That provides food for zooplankton, warming seawater. You can have potential for fisheries northward. But the time frame is probably a lot further out than the near term. It's not not next year, maybe 10 years, maybe. But that I can't speculate. Well, I mean, they're looking north, there's no question. The commercial fisheries are looking north, but they have a higher probability of getting fishing commercial levels over in the Barents than in the Chukchi.
Any other questions in the room?
Hi, Brian Kahn, Climate Central. I'm just kind of curious about, I see that there are some topics that sort of move in and out of the report card in different years. So polar bears has been added this year. It wasn't around for a couple of years. Reindeer have dropped off this year's report card. I'm wondering how you identify topics to cover, and if there are any topics that you're currently, would love to see regular coverage every year, but just aren't able to cover all the time.
Well, the The report card this year has undergone a change in organization and structure and size. We shrank it. And what we've done is we've identified 7 core topics which we plan will be updated annually. And then we will add topics on top of those, 3 to 4 to 5 each year, that will be updated less than annually. So for example, this year we made the difficult decision to not include permafrost, for example, and glaciers and ice caps outside Greenland, UV radiation and ozone. And so in future years they will reappear. Maybe every 2 to 3 or 4 years they will be updated. And this is also a reason why we instigated an editorial advisory board to provide advice on that kind of things, on which topics we ought to include in this report card, in a particular report card year. So the advisory board are eyes and ears out there in the research and scientific observing community who can tell us what happened this year, what is a particularly important event that happened in a particular component of the Arctic environmental system.
Yeah, can I just add to that, in making this decision about what we saw as the so-called 7 vital signs, I think is how we title it on the report card, it really does reflect the observation base that we have available. For instance, you'll see that most of those signs really depend highly on satellite observations, which are widely available both in a spatial and temporal context, and come to us and allow us to make an updated report. As you've heard Jeff talk about the difference between that observational capability versus the capability for polar bears. It's just a different world, if you will, with regard to what the technologies are for measuring.
Harvey Leifert, freelance. If I may, one more question on polar bears. I see on the map that there is a central area where there's an increase, and then there are stable areas flanking it, and then declining areas. Is there migration of the polar bears along that margin toward that central area, which may be more habitable for them right now?
Jeff,
is that why they're declining in one area and moving to the next?
Jeff, did you hear the question, and could you answer that, please?
Sure. Yeah, Jeff York with Polar Bears International again. Good question. We don't, of the areas where we have movements data from satellite collared bears, we don't see strong indications at present of outmigration on a scale that would justify some of the population shifts that we're seeing in the southern Beaufort Sea and in the western Hudson Bay specifically. In those areas, that question has been very closely examined as one, potential explaining factor. So that doesn't seem to be the case. Genetically, we know there is enough flow through among populations that the overall genetic signature for polar bears is fairly unified. When you start to look at much finer scale differences, especially with some of the modern tools we have in genetics now, we're seeing we can lump out approximately 4 what I call meta-populations of bears that actually correlate very nicely to physical habitat characteristics and what were termed ecoregions by Steve Amstrup back in 2010, 2008.
Any questions from the chat?
I have another question from Doyle Rice at USA Today. Are there any new updates or estimates on what year the Arctic might be free of sea ice in the summer?
I guess that's the $64,000 question. And of course, they vary quite widely. These are predictions based on computer models primarily, and some of them, they have quite aggressive outlooks for a very low or no summer sea ice cover, end of summer sea ice cover, and maybe that, some say that might be in 5 or 10 years. Others say the end of the 21st century. I think the important point about the models is not to dwell on the fact that they differ, but is to dwell on the similarity, that they all point in the same direction towards, if not a totally ice-free summer, end of summer, a greatly, greatly reduced ice cover compared to what it is today. And I think it's important also to not dwell on the idea of a totally ice-free Arctic. in the summertime because you don't actually have to reduce the ice cover greatly to change not only the physical and biological systems, but also issues of oil and gas exploration, tourism, fisheries. There are homeland and national security issues as well, and you don't have to go to zero for these to become a big deal.
Yeah, and if I can add, this is Jackie Richter-Mengy from the Cold Regions Research and Engineering Laboratory in Hanover, New Hampshire. That evidence that it's having an impact is already visible in the report card, and also as we see with regard to the level of activity and interest in the Arctic region. So it's already having an impact. We don't have to wait for it.
Any other questions in the room?
Hi, Randy Shostak again with EOS. I wonder if you could explain what are the most vital Arctic observing capability needs in terms of both capabilities that are already installed, capabilities that perhaps need more continuity, and why don't we have those things already?
How much time do you have, Randy? Well, the list is long, but certainly the 7 core topics that we've now chosen for the Arctic report card, let's keep those observations going. The sea ice, we must continue to monitor the sea ice throughout the year and for many years to come, similarly with the Greenland ice sheet and the glaciers and ice caps outside Greenland. The cryosphere, I'm biased, of course, because I'm a snow and ice scientist. But the cryosphere it's vital that we continue to monitor all the elements of the cryosphere. But because it's a system and changes in, for example, the cryosphere have biological and ecosystem effects, then there are various components of the biology and ecosystems of the Arctic that we must continue to monitor. As to why some things are missing, it always boils down to money, really, and priorities, that we can't do everything, or at least the United States can't do everything alone. And we will be continuing to collaborate with our international partners, for example, the 8 Arctic states, or the 7 other Arctic states of the Arctic Council, to better integrate and coordinate our observing capabilities and to share data freely and openly.
And if I could add to that, this is Mike Gill at the Canadian High Arctic Research Station. Martin already pretty much said it, but we're talking about an area that's about 30 million square kilometers. So it's about 3 times the size of Europe, and it's remote and extreme. So it's very difficult and expensive to monitor and study areas in the Arctic. But through the Arctic Council and other international initiatives, there is a lot more integration and coordination of how we observe the Arctic and collect data that is interoperable between our satellites and our on-the-ground measurements. So I would say that while it's a tall task, we're doing a much better job in moving into a place where we can start to better understand and answer key questions about the Arctic.
Could I ask Kathy Crane from the NOAA Arctic Research Program to say a few words as well?
Getting a word now. I just want to add some comments here. Thanks, Mike, for chiming in. That's very helpful. If you read through the report and the reports in the past, you will see that most of the physical parameters that are being reported on are obtained from satellite cover. That's a really thin skin of the surface of the Arctic, even the terrestrial world, the ice world, the ocean, and also the marine life. So there are tremendous gaps in the 3rd dimension or the 4th dimension. We don't have a sustained ocean observing system in the Arctic. We don't have a sustained, any kind of a system that goes full ocean depth that we can retrieve the information instantaneously and thus update the 3 dimensions of the Arctic on an annual basis. And I do agree that we need to do that, and I think the global community agrees that this is something that should be done. What Mike was alluding to is a program that we are actually involved with through the Arctic Council called the Circumpolar Biodiversity Monitoring Program. And that's being developed now with all the 8 Arctic countries. and has just been opened up to observer countries of the Arctic Council to contribute their data, because many of these countries, such as Korea, Japan, China, Germany, are contributing quite a lot in terms of data that could be tied into the whole observing process in a very regular way and a synthesis redone. For the Circumpolar Biodiversity Program, we have sentinel stations now that we're beginning to monitor. Each country is responsible for those. And the data are going to be put into various data nodes. Our node for the United States and Russia and the Pacific Arctic is the Alaska Ocean Observing System. These data will also be transported to the Arctic Portal, which has a secretariat in Iceland. So there are a lot of efforts internationally to move forward in this arena. And I hope that in the future we'll be able to report on some of these in a more regular way that puts flesh on the whole shape of the Arctic and look at the changes therein.
Thanks, Kathy.
Yeah. I have another question from the internet. This question is from Yerith Rosen at the Alaska Daily Dispatch. Yerith, can you hear us okay? I'm going to assume that she can. How strong is the link between Arctic warming and the changes to the jet stream, the changes that are bringing cold temperatures to the more southern latitudes and warm temperatures to the northern latitudes?
Well, we have down in the frontiers Steve Vavris from the University of Wisconsin and Jim Overland from NOAA Pacific Marine Environmental Lab, who I would ask to address that question, please.
Jim Overland with NOAA. That's a real interesting question that the scientific community is looking at because of its potential importance. The difficult issue is there's not a long time series, and the normal chaos of the weather is really large to find the cause from the Arctic. We know that the Arctic temperatures are greatly increasing, so the forcing is there, but the linkage is still circumstantial, that we've seen a more wavier jet stream in the last 5 winters compared before that, and so the potential is there, but the community is still uncertain whether that's primarily random or the sea ice or snow or other factors may be persistent. The main point is in the long term, with continued increases in Arctic temperatures, that it might be more of a reason for the mid-latitudes to have a more wavy jet stream, because it's all focused in one direction, but the attribution is still out at the present time. Steve, would you like to?
Yeah, Steve Vavris, University of Wisconsin. Jim just gave a really nice talk this morning summarizing this, where he described the situation as a pre-consensus period, where in which scientists who look at the same data sets can come to different conclusions. Perhaps they're using different methods, perhaps other reasons. So the jury is still out, I would say. Last winter, there was a lot of interest about whether the unusual weather pattern we had here in North America, very wavy, very stagnant, very consistent with what some people have proposed as being driven by Arctic amplification, whether that was indeed an expression of Arctic amplification. And there is not a consensus on that even. Some people say it was driven by the tropics, some internal variability, some people may have been Arctic driven. But I think the lesson we can get out of last winter as an expression of what can happen is that these wavy, highly persistent weather patterns can have a huge impact regardless of the cause. And if, in fact, they are going to become more common as a result of Arctic amplification, this is something that we really do need to resolve and get beyond whose method is correct and how to assess the data up to this point.
I think we have time for one final question. Is there any questions in the room? Any on the chat? Do you have one final?
All right, Susan Moran again, freelance journalist. What, if anything, do you hope to come out of the U.S. chairing the Arctic Council in terms of legacy, or, you know, not super detailed in strategy, but what should be different?
Simon,
I'd like, if I could just give my quick answer to that, and then I'll hand it over to Simon Stevenson from the Office of Science and Technology Policy in the White House. My hope is that at least we can raise awareness among roughly, 300 million Americans, the population of our country. We can raise awareness among that group that we are an Arctic nation and that the Arctic does matter to those who live in what Alaska calls the lower 48. But Simon, perhaps you'd like to add something.
Simon Stevenson, Office of Science and Technology Policy at the White House. So first say that the State Department are creating the package of proposals to discuss with the other Arctic countries. So what we're actually going to do under our chairmanship is not yet settled. That said, one of our priorities is to understand the Arctic's role, to better understand the Arctic's role in climate and how, and perhaps begin a set of mitigation activities with those Arctic countries, even though they may not have a huge impact on the changing Arctic. They are starting us in the right direction. So that would be one positive outcome of the chairmanship.
Okay, thank you. That wraps up this press conference. I think we have another one at 11:30 on Greenland. Oh, Arctic heating, 15 years of sea ice loss and absorbed solar radiation gains. Sorry about that. Thanks.